Alright guys, so over the last few years I've had quite a few titles, including soldier, cowboy, scientist, Uncle Chewy. Some people have even called me the cattle baron of the neighborhood. And in this episode, you can call me Professor, because we're going to be going over some advanced ball python genetics. Alright, to start off this class, I'm going to start out with a show and tell. And I have a snake over here that needs a little assistance. So check out this white albino mainland dwarf retic. Her name is Lucy, and she destroyed her cage. So she's been feeling pretty ill, and I've been giving her some. Her mouth is really swollen from rubbing on the cage, and it looks really good now. I've been giving her some F10 vapor. And she's been really grumpy. The last time I tried to pick her up, she was hissing and bucking, and and then she went into shed. And after they shed, they make a mess, go to the bathroom, and she needs to be moved. So I'm going to move her over into this clean tub over here. And I'm going to set up this tripod, and you can watch me. And if the professor gets bit, don't do it that way. Do like I say, not as I do. So hopefully this will go good, and I won't take a bite, and she'll be in a good mood. Alright guys, so if you're messing with a big snake, I always recommend going with the snake hook to kind of feel the mood of the snake and see how she's doing. And she seems like she is doing okay. So, let's take a look at, big old Lucy here. She feels like looks like she lost a little weight here. But she is a big girl. Really big. Yeah. So take a look at this. This is what I really like about my snake room here is she actually reaches from one tub to another, and I always have a spare tub. And you know, I've seen some people take the snake out, put him in a box, and then try to get him out of the box and back into the tub. And this always works really well for me, from going straight from a dirty tub right to a clean tub. And, woo! She is a monster. Look at that. Ah, yeah. She's in a really good mood, actually. I'm kind of surprised. She's feeling good. She's set out, and her mouth is doing really well. Take a look at that beauty. Oh, she's hissing a little bit. Alright. Maybe not feeling the greatest still. Ooh. Alright, Lucy. Whoa. Yeah, the trick is keeping them in the tub. Woo. Alright, yeah. Alright class, show and tell is over. Let's move on to the topic of discussion, and that is ball python genetics. So let's start with the basics and kind of move to the advanced genetics from there. So most genes or morphs, so any color and pattern of a snake is we call it a morph. It's basically a gene, and every single gene is either recessive or it's dominant or co-dominant. You hear some of these terms, and if you mix certain genes together, it can have one copy of different genes and be allelic and act as a super. You can also have a recessive gene. You have one copy of the gene or two copies. It's homozygous or heterozygous. So if it's het pied, it's heterozygous for pied, has one copy of the genes. And all of that is kind of, I would say it's the basic groundwork of genetics. And that's where most people kind of start and end. And now let's get into the more advanced genetics. And that is really kind of like I would say, kind of like the advanced calculus of genetics, per se. So in order to know the genetics on this level, you basically have to know some of the genetics are only associated with one particular morph. And I'd kind of like to go over what some people would call defects in ball pythons. Not necessarily defects in all cases, but it's kind of like genetic anomalies, I would say. And the first one I want to cover is what we call the wobble. Okay, if you're thinking of the wobble, most people think of it as a spider wobble. And I actually have a spider with what we call a spider wobble. And it's actually a spider pied. And if you look at him, see how his head's kind of sticking straight up? That's not really normal for a ball python. And this guy is pretty a severe case of spider wobble. And you can kind of see, if you kind of lay him flat on the ground, but if you kind of see right there, that is definitely a spider wobble. It doesn't affect his ability to eat or breed or thrive. It's just kind of a weird anomaly. And this is kind of, I would say, a moderate case. And I've actually seen this in other morphs. So it's not necessarily specific to a spider. I actually walked into a pet store one day, and the first time I ever saw a champagne, I went to this pet store, and I thought, oh, I mean, the champagne is just a beautiful morph. They used to sell for a lot of money, and I think they kind of went out of popularity because it has a wobble. And similar with the spider, a lot of people kind of shy away from the spider just because of the wobble. And when I went in that pet store and saw the champagne for the first time, it was literally crawling upside down on its back. It's like the upside down snake. It was the weirdest thing I ever saw. And it's actually associated with a few other genes. So I've heard the WOMA and the hidden gene WOMA also have a wobble. So there are also some super forms that have a wobble. One of them is the super sable, and the Powerball, which is the super spot nose, and I believe it's the if you kind of cross certain genes together, so you can have like a champagne hidden gene woma, and that'll have severe wobbles. So you really have to watch out for those combos as well. Okay, so let's talk about lethal combinations. So in this case, you actually have two snakes that form basically a snake that has a copy of one gene from each of the snakes. And they say, from what we have seen, from some of the hatch results and the historical data, some of it is, some people can kind of disprove it, and it's a little outdated. And sometimes it's really hard to find good information on some of this stuff. But as far as we can tell, when you breed spider to spider, it's a lethal combination. And the same thing if you breed spider to sable, or spider to champagne. And I know there's been a lot of debate over spider to spider, so there's some people that say, I've actually seen people with eggs that they open them up and there's like a white snake in there, and they say that that white snake is a super spider. But I don't know, I've opened up some of the dead snakes on my albinos where they fully developed and then died, and those look white too. So, and I don't see any kind of a white snake in a like a super albino or anything that could have came out of my albino pied crossed with my albino, which is kind of weird. And I've also heard some other people say that that they don't think the super spider is lethal. It's just not possible with a combination. So you can breed spider to spider, but something with the gene prevents it from getting two copies of the gene in the same place. And a lot of people said they've bred spider to spider for years and years and years and never produced anything dead in the egg or produced a super spider. So that's that's kind of a that's kind of an anomaly. The jury's still out on that one. Okay, so let's talk about the desert gene. And if you're thinking about getting into the desert project, it's a little bit confusing because there's another gene called desert ghost, and even more confusing, there's a gene just called ghost. So you can actually get a desert ghost, which is one gene, and a desert ghost, that's two genes. and so I'm actually in the desert ghost project. So take a look at this. You've probably seen this before. Here's my desert ghost male, and he is a beauty. He's a wonderful, beautiful snake. And he is one of the most, I think he's one of the prettiest snakes I have in my collection. And that is a pastel with a desert ghost. That's all it is. Which is pretty amazing that the desert ghost does that to the pastel. And if you take away the pastel, I'd say it's kind of a khaki colored a little bit. And it definitely breaks up the pattern, almost like it turns the pattern kind of into an enchi, but there's no enchi in this snake, which is kind of interesting. So a lot of people that are breeding desert ghosts, especially if they're selling them at the shows, they'll actually put on their display case, this is desert ghost, not the desert gene. And the problem with the desert gene, when it first came out, it almost looked just like the desert ghost. And the desert ghost is a recessive mutation. The desert is co-dominant. So basically you breed a desert to a normal, half the babies are desert, and it almost looks, as impressive as that. And I remember when they first came out, all the breeders were like, "Oh, this desert's great! I want to breed it to everything and run it through my whole collection." Come to find out, there was some genetic anomalies with the desert. The males were fine; you could breed a male and produce a bunch of offspring, but there was a problem with the females, and the females. They said the eggs were not viable. So you had all these females, and none of them would breed, which, they breed, and so I heard different stories that they'd actually breed and they'd lay eggs, and none of the eggs would develop. And then some people would say that actually when the females were full of eggs, when they were gravid with eggs, something happened internally and they would pass away when they were full of eggs. So now, if you look around like a morph market, you can still find desert genes floating around, but most people say pet quality only, or they go through the whole explanation. If you have females, do not breed the females, only breed the males. Okay, so let's move on and talk about the duckbill. So basically what that is, you'll have duckbills on just a couple snakes, and it's where their head's kind of flattened and the sides of their mouth kind of pan out, and their head kind of looks like a duckbill. And we really only see it with the super cinnamon and the super black pastel, and it's really unfortunate with the super black pastel, because if you've ever seen the panda pied, it's a pied with the super black pastel, and it's a completely stark black and white snake. And I would say that the whole problem with the duckbill is the thing that really keeps a lot of people from getting into the project. The demand is really high and the supply is really low, I would say, because of the duckbills, which really drives the price really high. So I actually just looked on Morph Market just a few minutes ago. There was only 3 of them on there, and all 3 of them were $10,000 a piece, which is really crazy. And another one that kind of breaks my heart is the gray matter. I don't know if you've ever seen the gray matter ball python. You can actually go to Morph Market, do a filter and type in for the gene gray matter and hit search, and it'll actually break out that name into the 2 genes, and it's basically a super black pastel and a champagne. And if you mix those 2 together, what you get is a pied. Instead of the black portions on the pied gene, being kind of a black and brown, they look almost like a metallic silver gray color. And it looks like a pied, even though there's no pied in there, because sometimes when you mix champagne with different genes, you get like a pied looking snake. As a matter of fact, if you mix champagne with pied and you get a champagne het pied, that almost always looks like a visual pied being het pied. And if you get a champagne pied, it turns into a white snake, which is kind of interesting with the champagne. But the thing with the gray matter is you got the champagne, so you got the severe head wobbles, and you got the super black pastel, which you get the duckbill. So it's almost like a double whammy on that snake, you know. And sometimes you can find examples where they don't have a duckbill and they don't have a wobble. But if you're breeding into that project, you just have to really be careful and kind of watch your bloodlines. And I guess you're rolling the dice when you start breeding the gray matters. Okay, so let's talk about bug eyes and micro eyes. So there's only one that I know of that'll give you bug eyes, and only one combo that I know of that'll give you the micro eyes. And I happen to have a snake with the micro eyes, and that is my lesser pied. And I didn't even know about this girl having micro eyes until I actually got her and started researching ball pythons. And if you notice, she's got bright blue eyes too, and it's almost like a blue-eyed leucistic when you mix the lesser with the pied. And her head shape's really kind of weird too. So she has kind of a weird head shape and micro eyes. And the lesser, if you mix it with the pied, you always get an all-white snake with small eyes. And so if you kind of look at the individual genes, the lesser and the pied, I can show you examples. Let's see what I have here. So this is basically what a pied looks like. I'm sure you've seen a pied, but that's just the straight pied gene. You mix that with the lesser, and you get the lesser pied. And let me pull down my lesser, and I'll show you what she looks like. Okay, so this is my big female lesser. And I'm actually hoping she'll breed this year because she didn't breed last year. She's a really beautiful snake. So basically just one copy of the gene, the lesser gene, and it's a codominant gene. So if you breed this with a pied, which the pied's recessive, but you breed it with a pied and you get a lesser pied that has the micro eyes. Well, if you breed a lesser with a lesser, a certain percentage of the babies come out as super lessers. And the super lessers have bug eyes. So basically, something with the lesser affects the eyes when you make the super, or if you mix it with the pied, which is really unique. Okay, so let's talk about potential issues with the albino gene and the caramel albino. So some people say that in certain lines of caramel albino, they see kinking, which is basically where they're born with a deformity of the spine and the snake can't completely straighten out. And then I've read other reports of people saying, oh yeah, I've been breeding caramel albinos for 30 years and I've never had a single caramel albino that's been kinked. And then other people say that, you know, they've also seen it in lavender albinos, and I've seen it in lessers, and I'm not sure exactly what causes the kinking, if it's inbreeding. Some people think it's you know, that the albino has just been around for so long, since the very beginning, that there's just been a lot of inbreeding over the years, just breeding back to the same snake, brothers and sisters, moms and dads, and so on and so forth down the line, that they're all closely related, and that maybe gives you some of the problems. And I do know on my albino, when I mixed my albino pied with my albino, I had some issues there, and I'm thinking a lot of the issues aren't necessarily associated with the gene. I'm thinking they're more associated with the lineage and the inbreeding. So I would say if you're breeding two caramel albinos together and you get some kinking, maybe find a different parent for one of them and kind of switch things up and see if that helps. But I think the jury's still out on that one too. Alright guys, so I'm going to leave you with one more genetic anomaly, and it's only associated with one snake, and that is the coral glow, also known as the banana, and the whole issue with male makers versus female makers. And that is a really interesting topic, and it's extremely complicated. I actually have a video, male maker versus female maker. And the females are perfectly normal. They produce a normal ratio of males and females, but it's the males that will produce either all female, mostly all females, or mostly all males. And for a more in-depth explanation, I go back to my video and kind of look at that video and how I explain it. So this is actually a male maker. This year I produced a whole bunch of coral glows, and every single one was a male. And somehow the gender of the offspring is linked in the genetics of the snake, and it's a really weird kind of genetic anomaly that no one has ever seen in any other ball python. And a lot of these, you just really have to know kind of the project you're getting into, some of the genetic anomalies, and kind of what you have to watch out for. And some of these, I mean, if you got into the panda pied, you paid $20,000 for a pair and you didn't realize, you know, what you're getting into with the duckbills. And you know, they say some in some cases they've actually seen kinking in the super black pastels too. And I'm not sure with the whole kinking thing. I'm not convinced that it's really genetic, but some people are convinced. You know, a lot of people stay away from certain genes because of it. So that's pretty much class dismissed on the advanced genetics of ball pythons. Thanks for watching, and I will see you next time.